Good morning and welcome everyone. This is a session on at the Raw Material Week, specifically looking at how we can go towards an Earth observation platform for raw materials. And we have a nice agenda this morning with many speakers who will be addressing these issues. My name is Mark Darrell. I'm from the European Commission's Joint Research Centre, where I'm a project leader for Copernicus, scientific and technical support to Copernicus, and I'm also leading this new knowledge centre on Earth observation together with the colleagues in DEFIS. During this session, we'll have various speakers, and there'll be the opportunity for you to ask questions after their interventions. And there's a question and answer session on Slido. I believe my colleagues will be putting up the Slido link on a slide in the moment, but it's anyway on sly.do, and the hashtag is EO4RM. That's EO number 4RM for raw materials. And I'll also be launching a word cloud in there, a word cloud poll that will be open throughout the session. And I'd invite you to give some suggestions in answer to the question, what products and what Earth observation products and services do you see relevant to addressing raw materials? And we'll come back to that during the coffee break. Anyway, to start this session off, I'd like to invite Matthias Peschke, who is the Director for Space in DG DEFIS. I should say this whole session is co-organized between DG GROW, DG DEFIS, with the colleagues from the European Space Agency, ESA. And Matthias will provide us some introductory remarks. So Matthias, the floor is yours.
Thank you. Thank you very much, Mark. Colleagues, pleasure to welcome you and to open this event on exchanging ideas towards an Earth observation platform for raw materials. I'm grateful for the good cooperation in the run-up to this event with the colleagues mentioned from DG GROW and from the European Space Agency, and obviously in close cooperation with my team here at DG DEFIS. My name is Matthias Peschke. I'm the Director for Space at the Director General for Defense Industry and Space. And I would like to open this event by saying some words about Copernicus, which is the Union's Earth observation and monitoring program focusing on our environment and on security. It is the largest space data provider in the world. It makes available petabytes of global data from satellites, integrated together with ground-based, airborne and seaborne measurement systems and with modeling capacities. And the Copernicus services transform this wealth of satellite and in situ data into value-added information by processing and analyzing the data and providing the final users with tailor-made products. The Copernicus services provide long-time data series covering several decades at relevant temporal and spatial resolution, allowing us to detect changes and trends in our environment and to model the possible future under different scenarios. The program provides this information in free and openly accessible manner to help service providers, to help public authorities, and all the other users to improve European citizens' quality of life. Some words about Copernicus for raw materials. The information provided by the Copernicus services can be used by end users for a wide range of applications in a variety of areas. Copernicus can contribute to sustainable supply of mineral resources with global coverage of Earth's land surface and open and free data, and provide efficient solutions for the raw material industry. Several types of products are already in use by mining and raw materials companies to help in exploration and monitoring environment around their operations. There are also other products and information provided by Copernicus that can be further developed in support of the sector. And I can give you some examples. Maps of remote infrastructure, roads, water, landing strips, etc., necessary to support mine development. The combination of land cover products with geological surveys to prospect mineral deposits. The use of the ground monitoring service of Europe from Copernicus to map ground stability during exploitation and in abandoned mining areas, and environmental monitoring to detect any pollution or its extent to meet regulatory requirements. There is also a huge potential for further development and strengthening our knowledge of the applications of Copernicus in the domain of raw materials generally. The next years will be very important to scale up significantly the Copernicus Earth observation capacities with the new Sentinel units flying and the coming expansion missions. These new capacities will bring additional capabilities to be explored by the raw materials sector with new and improved measurements on new applications, such as hyperspectral imaging and thermal measurements. And in addition, development of digital technologies, increase of cloud services, and the rise of computing power open the door to huge number of new applications based on Copernicus data or combining with other type of information. Copernicus is already co-located with cloud computing resources in the DIAS to foster the development of applications and user uptake. They provide centralized access to Copernicus data and information as well as to processing tools. In this sense, developing an Earth observation platform for raw materials that can be built on the Copernicus DIAS subscribes well in the overall context of Copernicus technological evolution. It will enable further extraction of value from Copernicus data and information. And finally, the Knowledge Center on Earth observation from the Director General JRC, there will be a further explanation with regard to this in a moment, may help to coordinate and to fully exploit the potential of Copernicus data for the raw materials sector. So as you can see, Copernicus is able to bring a huge amount of data and applications for the raw materials sector, and it is up to us, up to you, to explore this to its best extent. Combining the power of Earth observation data and new computing technologies is a way to the future. Development of an Earth observation platform to enable access to Earth observation and derived results for the raw materials value chains is a good way forward. I hope that this event will prove its value and will bring new ideas to the table. Thank you very much for your attention and have a good day with presentations and good discussions. Over to you, Mark, again.
Thank you very much, Matthias. Thanks for providing a very comprehensive and broad overview of the potential that Copernicus offers, in particular the products and services it could provide to the area of raw materials, as well as, of course, what we can expect to see as increased capability in the context of the planned expansion missions. I'd remind our audience that we do have this Slido, which is where you will be able to ask your questions and answers to the following speakers. And also, as I said, there's a poll, a word cloud poll that is open there now, and where you can express your opinions, let's say, on where you see priorities for products and services relevant to raw materials. So now we're going to start off with our main speakers. In these, I remind each speaker they have between 10 and 12 minutes to speak, and then there'll be a few minutes for questions, to take any questions. As we said, this session is a partnership between DG GROW, DG DEFIS, and the European Space Agency. And our first speaker is, in fact, from the European Space Agency. This is Zoltan Bartilis, who is Earth Observation Application Engineer at ESA. So Zoltan, the floor is yours. Thank you.
Yes, hello. Hi, everyone. My name is Zoltan. I'm from the European Space Agency, working in the Directorate of Earth Observation Programs. I'm just going to give you a very short overview of what's new, the general trends here at ESA regarding raw materials and the mining sector. Next slide, please. So quickly about us, we are an intergovernmental agency, 22 member states and 4 associated or cooperating members. ESA covers all aspects of space, research and technology and their applications. We have developed over 80 satellites and tested and operated them since 1975. Our budget for this year is 6.5 billion euros, of which a large share, about 1.4 billion, is allocated for Earth observation. So Earth observation is our biggest program. Our member states have the possibility of subscribing to these on an optional basis. Next slide, please. You've probably seen this before, this slide. It's we keep showing this because we think it gives a very good overview of the present and the future of Earth observation missions at ESA. We have 16 satellites in orbit at the moment. At the moment, we are developing 38 more, and 14 are in the planning. On the right side, you see a band of a category of missions, which is the meteorological missions, a special branch of Earth observation that is mature enough here in Europe and elsewhere to be handled by a dedicated organization in Europe called EUMETSAT. In the leftmost band, you see our scientific missions addressing questions of Earth science based on specific issues raised by the science community. Here we have the so-called Earth Explorers, which have been with us for quite some years now, but also we have a new addition, the Scout missions, where the idea is to prove new concepts using small satellites to add scientific value to data from current satellites. And these adopt an agile development process for a maximum cost of 30 million euros for the entire mission. In the middle, as we heard already, we have the Copernicus program satellites, the Sentinels. These are the workhorses of operational Earth observation at the moment, not just in Europe, but also being used worldwide. Right, so next slide, please. Just quickly throwing in this slide to show you that we actually, in our Earth observation program, we work very much on user requirements. So we build satellite missions based on requirements from the users. On the left, you see the scientific missions are driven by the partners in the member states through open calls. And the blue field of this slide shows our international, institutional partners, the European Union for Copernicus, EUMETSAT, as I said, for meteorology, but also we have a line of in-cubed missions, which are directly with industry. Next slide, please. Just adding this to give you a reasonably recent overview of where we stand with the planning of the upcoming Sentinel missions, Sentinel units, more specifically. I'm not going to explain this. You will probably have access to this slide later on. Let's now talk, next slide, let's now talk about the capabilities of Earth observation missions. In the case of raw materials and mining. So what can satellites do? As you can see on the right, this is nothing new. I like to show this, this image because it's this screenshot of an old document, an old publication from 1974. This is what I found to be one of the first, if not the first study using satellite data from mineral exploration, using Landsat-1, which at the time was called ERTS. And indeed, the combination of optical and microwave signals proves very useful for providing a wide range of information, as we heard also mentioned by Matthias in the previous presentation. And all these products can play a large role in every stage of the mining cycle, from prospection and exploration to mine planning, operation and closure, reclamation and rehabilitation. Next slide, please. I'm mentioning this activity that we finished last year called the Earth Observation Best Practices in the Mining Sector. We tried to figure out what geoinformation needs there are in the sector and derive best practice guidelines on how to use satellite data to cover some of those needs. We also try to understand where we stand today with the EO technology relevant for the mining sector and mapping which capabilities are underused and would be relevant in the near future. So on the link displayed there, you can access about 60 geoinformation needs and challenges, which are mapped to about 30 EO products described with their own product sheets, specifications, availability, and so on. We did this together with the European Association of Remote Sensing Companies, who is a very good place to try to organize this kind of information in a more structured way. One of the possible channels for disseminating this kind of knowledge. Next slide, please. Right, so if we look back to this first publication from 1974 and one of the main applications of Earth observation, we see that there's been a lot of progress. Large-scale geological mapping today is very much supported by a synergistic use of different satellite data sets. It's a time-saving and cost-effective method for geological mapping, for interpretation and mineral resource exploration. Of course, when we have bare ground or semi-arid to semi-arid situations, we have very good results. But also when we include microwave missions like SAR missions, for example, Sentinel-1, even in strongly vegetated areas, we managed to do some interesting structural interpretation, as seen here in the bottom row of images. Just giving you a few more examples of applications. It's not the point of this presentation to go into very much detail. Next slide. Of course, one of the most interesting applications out there is relies on the radar interferometry. This is an example from the Cadia gold and copper mine in Australia, where in 2018 there was a tailing dam wall collapse. Very important here, if you click further in the slide, you will see that there's been good progress towards adopting satellite radar interferometry as a key tool contributing to the regulatory compliance and accountability for the mining industry. We see here, next slide, please. Yeah, we see here a recent publication from last year, the Global Tailings Review published the Global Industry Standard on Tailings Management, where we see that at least they have laid out principles for designing and implementing and operating monitoring systems to manage risk at all phases of the facility lifecycle, where really Earth observation is the adequate tool to do this in a very objective and systematic way. Okay, next slide. Another example is where EO can play a role is stockpile monitoring. We see now that more and more optical and radar data become available to be able to monitor in detail the activities for stockpile volume estimation. Here in this example, we used Pléiades and SAR data, and you can actually build a timeline of the relative volume change based on this, and applying some machine learning to try to understand which shapes of these stockpiles are to be observed. Next slide. Yes, but we are aware that there is still a lot left to do to achieve our vision longer term. And two important points of this vision that we have in ESA, but I think also in the Commission, is that we need to embed Earth observation into operational working practices. And the other one is to accelerate the availability and understanding of new technologies and data sources. On the first point, we think that we need to keep building industry-level acceptance and compliance with best practices, but also we need to talk to governments and regulators to build acceptance with them as well. And we need to engage the right stakeholder communities and their relevant intermediaries, like engineering companies and so on, to address sector-wide issues. And if we achieve a critical mass of actors, for example, certification, that's the only way it will work. And a very important point is that we need to make, as we heard before, we need to make the access to Earth observation data trivial. So we need to migrate to cloud-based processing for all data access and analytics. We need to organize and release the data in data cubes and other forms of easily accessible analysis-ready data. And we need to connect Earth observation to effective and well-understood state-of-the-art artificial intelligence for platform-enabled heterogeneous data fusion, meaning that the artificial intelligence in itself is a great tool, but we need to connect this to all the plethora of data that we have. And on the new space, as we call it, the new space capabilities, so the new way of doing space missions, we need to reach a higher performance cost ratio by building smaller satellites, better sensors, to lower recurring costs. We need to continue miniaturization of these hardware and launching constellations. More autonomous satellite platforms, distributed ground segments is all part of it. And there's a series of new technologies or emerging, well, actually, it's not really an emerging technology, but only now we see that technically all these things are feasible, like multistatic SAR, satellite video, passive microwave, and upcoming hyperspectral missions. This should be the central missions in this respect. And pattern recognition, all kinds of techniques to work with data, hybrid artificial intelligence for complex analysis, and super resolutions. And of course, synergies with all other data sources like aerial, IoT, high altitude, pseudo satellites, and also crowdsourced data. Next slide. Oh, we actually managed to make the animation work. That's nice. Thank you. Here, just to illustrate very quickly the new and upcoming type of satellite missions and their data. This is ICEYE, which is working towards a constellation of 18 SAR satellites. We will see a bit more examples of this in the presentations afterwards. And but here you can actually see that the activities in the harbor area, which is very similar to a mining area, are monitored in detail on a daily basis with these very good resolution SAR satellites. And on the right, you can see accumulation of lava, which I think is very similar to stockpile monitoring in a way, which is also very feasible nowadays with this kind of radar constellation. Next slide, please. Oh yes, this is also working. This is very nice. Another example of recent mission is the NEMO HD mission, the first Slovenian microsatellite, which I don't know if you noticed, there are, this is a mine in Australia, the famous Kalgoorlie mine. You can actually see that the vehicles are moving. This is a recent acquisition, about 19 seconds of video data. And it's really amazing that the satellite, while acquiring this video, the satellite is actually traveling about 150 kilometers. And this is the type of stable video that we can obtain nowadays from satellites, from really microsatellites. Right, next slide. Just quick example of one of these techniques that we in ESA are working on, super resolution. How to go from a low resolution image, apply some algorithm, do some learning on training data using convolutional networks, for example. And on the right, you can see the level of 4 times enhancement of the resolution that could be possible. Next slide. About data cubes, I won't go into detail. We have already first results of creating data cubes, not only from optical data, but also creating analysis-ready data sets based on interferometry and radar data. So all this work with the ground motion can also be facilitated. The next slide, you see what Matthias also mentioned are the upcoming Sentinel missions. This is CHIME, Science and Applications, the first routine hyperspectral measurements in the Copernicus program. This is still down the line. The launch is foreseen in the second half of the decade, but we need to be working towards understanding more this kind of mission and the data it provides. I'll skip the next slide, which gives us new issues, because every new development brings issues. Actually, that's not the next slide, but fine. Just wanted to mention what you will hear probably from my colleague Rado also presenting, and we heard already in the previous presentation, the Earth observation platform for raw materials. As a goal, we would like to contribute to creating such a platform. And we think that the mining community and the raw materials community can benefit a lot from this kind of customized community-driven platform. And just to let you know that we are supporting the EU-Ukraine strategic partnership on raw materials. We think that working with the Ukrainian colleagues is a perfect framework for piloting the first instance of such a raw materials platform. And this platform will respond to specific requirements from the Ukrainian counterpart. We are now working on the next slide. We are now working on 2 pilot demonstrations that could feed into this kind of platform. In Ukraine, one of them is the feasibility of assessing the quality and quantity of minerals in mining waste areas. And the second pilot would be on the impact of quarries on their surroundings, on the ecosystem, the landscape, and the water resources. This will all be implemented, these first 2 pilots, in what we call the Earth Observation Clinic, which is a mechanism for supporting development projects, and it could be scaled up in the future together with the European Investment Bank or the European Bank for Reconstruction and Development, EBRD. Right, that's it. Next slide is already thanking you. So thanks a lot.
Okay.
And
thank you.
I'm really thankful to our colleagues in the Commission for making these regular events possible. I think it's really a good opportunity for keeping us updated on what's going on. Thanks a lot.
Thank you. Thank you. Thank you very much for that, Zoltan. So we don't have really much time for questions, but I'll just ask a very quick one that came up, which you started to allude to when you were talking about the CHIME mission towards the end of your presentation. But of course, Matthias had already mentioned the expansion missions. Where do you see specifically for the raw materials sector additional products coming from the planned? So you mentioned, of course, the hyperspectral observations from CHIME. So can you just give a flavor of what type of products you see coming out of that and maybe other expansion missions very quickly? Thanks.
Yes, well, CHIME as a hyperspectral mission is obviously will be a very important contribution, but we have also, as I mentioned, small satellite missions developed by industry in our member states that will fill the gap until the launch of CHIME. And as we've seen on the video side, for example, we have very interesting applications showing the dynamics, helping in understanding, supporting the operations of in the mining activities. So I think there is a very good potential, for example, also for the enhanced air quality products coming out of Sentinel 5P and also the Sentinel-5, Sentinel-6. All of these missions can contribute to understanding what's going on in an intensive industrial area like the mining sites worldwide and seeing the pollution. Thank you.
Thanks. Thank you very much, Zoltan. And thanks for your interventions before as well. So now we'll pass to our next speaker. And our next speaker is, I actually believe, one of the chief architects of today's workshop. So Gerardo Herrera from DG GROW. Gerardo is a policy officer and is working specifically in the energy intensive industries and raw materials unit. And as I said, he's been a key player in getting today organized and a key advocate in pushing for Earth observation for raw materials in the Commission. So Gerardo, the floor is yours.
Thank you very much. Do you hear me? Because I see my image squeeze.
Yes,
yeah.
No, I hear you.
Okay. I see my image frozen. Do you see my image? Okay, anyway. So thank you very much. Thank you very much for this introduction. I'm going to present you some EU policy context for this initiative of the Earth Observation Platform for Raw Materials, the plans we have and the international partnerships that we are trying to develop. Next slide, please. So the policy context starts with the European Green Deal. This is our climate neutral ambition to be achieved by 2050. After this policy, several policies developed about the industrial strategy, circular economy action plan, the recovery plan, and here today, the critical raw material action plan. Next slide, please. The goal today is to try to see how Earth observation can better contribute to implement these raw material policies. Next slide, please. In this critical raw material action plan, we publish a list of 30 critical raw materials. This is something that has been done since 2011, and an action plan. Next slide, please. These critical raw materials are critical because they are needed by key technologies, enablers of this key climate neutral transition, like the batteries, the fuel cells, the wind turbines, the traction motors, or the solar panels. We need these critical raw materials for these industries, but at the same time, they are provided by few countries. This is why they are at supply risk. Next slide, please. We see, for example, in this slide that 78% of the lithium that is coming to Europe is provided by Chile. 85% of niobium is provided by Brazil. Rare earths are provided by China. And today we are hearing a lot about magnesium. 93% of the magnesium coming to Europe is provided by China as well. So this is why this is a supply risk for Europe. Next slide, please. So together with this list of critical raw materials, we published the 10 action plan. The 10 action plan that is aiming to increase domestic sourcing, increase circular economy by recycling, substitution, reuse, and more importantly, develop international partnership with resource-rich countries that want to develop mining in a responsible and sustainable way. One of these 10 actions is specifically to develop Earth observation technologies for raw materials, and this is why we're here today. Next slide, please. But from these 10 actions, at least 4 of them are related to Earth observation technologies that could be improved. For example, Earth observation can help to map secondary critical raw materials by identifying mining waste of or urban landfills. Or we can help to define mining projects that can be operational in 25, or promote responsible mining practice by monitoring the ground stability or environmental impact. We can also help in other international partnerships to develop them with Earth observation technologies. Next slide, please. So going into the Action 7 related to Earth observation for raw materials, we see other policies that connect with it. For example, the EU Space Program, where we have the Copernicus Land Monitoring Service, or the thematic exploitation platforms from the European Space Agency, or as it was presented before, the Knowledge Center for Earth Observation. We also have the European Union Space Agency that is developing these Earth observation technologies. Next slide, please. Regarding the state of research and innovation, we have seen in H2020 program 4 projects related with Earth observation technologies for raw materials, related with innovative exploration techniques, or artificial intelligence for mine monitoring. As Zoltan was saying before, ESA has funded this project on best practice for Earth observation and raw materials, and later we will hear from Patrick about the EIT raw materials efforts to build capacity building for Earth observation and raw materials through the ROMATCOP program. In the current Horizon Europe program 21-22, we have one topic that directly relates with Earth observation for raw materials and others that are in a way interconnected. Next slide, please. So if we go or jump into the EU Space Program, we are interested, or we see an interest in the Copernicus Land Monitoring Program. There, specifically, the local component of the Pan-European Marine Land Cover could be useful, but also the coming European Ground Motion Service that it will come next year, or the thematic exploitation platforms from the European Space Agency, or the scientific program from ESA that was explained before by Zoltan. Next slide, please. As it was previously introduced, the Commission launched in April 21 the Knowledge Center for Earth Observation, and this is all about trying to improve or enhance the use and the uptake of Earth observation technologies for the EU policies, and this is why we are here. We want to enhance the use of Earth observation technologies for the raw materials. Next slide, please. So if we go into more detail into the Copernicus Land Monitoring Service, we believe that new local component products could be made for the raw materials. For example, trying to map these secondary raw material sources by mapping urban landfills and mining waste areas in the EU, using this local component of the Marine Land Cover, which allow us to have resolution of 0.25 hectares. This would be a similar product to the Urban Atlas, riparian zones, Natura 2000, or coastal zones. Next slide, please. Another idea is to try to use European Ground Motion Service to map the ground stability of abandoned mining areas in the whole EU. This European Ground Motion Service, starting next year, will provide a ground deformation layer for the whole Europe with millimetric accuracy and a resolution of 100 by 100 meters. So it's something that we can apply to all these mining waste areas in the EU to understand the stability of these areas. Next slide, please. We also have the possibility to create a raw material thematic exploitation platform from ESA. Currently, we have 7 of them targeting coastal, forestry, hydrology, geohazards, polar, urban, food security. Why not having one specific for raw materials? These platforms accounts for software, services, infrastructure data that allow to exploit Earth observation data, but also to exploit the results of this Earth observation data exploitation. The stakeholders are wide. We go from the researchers to the software providers, data owners, or end users, that in the case of the mining sector could be the mining industry, the mining authorities, the research institutions related to the mining raw materials. Next slide, please. So if we try to put together all these ideas, there is when we came up with this concept of the Earth Observation Platform for Raw Materials in collaboration with European Space Agency and DigiDefis. This is all about trying to not to start from scratch, but try to put together in a platform, in a digital platform, all the 16 tools or data that are already available or more or less available. This platform could include mineral exploration tools, Copernicus data, mining monitoring tools, capacity building programs, and even, as Zoltan was saying, standards to define these existing products and services. This could be on the cloud platform providing services and data. Next slide, please. Let's go into more detail on this. Why it's a good idea, this Earth observation platform for materials? Because we believe that we can foster the exploration of primary, but also secondary critical raw materials contributing to the circular economy. We can monitor active and abandoned mining areas and enhance operational safety and sustainable mining. This can be useful for the EU, but it can be also useful for non-EU countries, and we can develop this through our strategic international partnerships for raw materials. And we don't start from scratch. We can create this platform online using Earth observation, Copernicus data, services, and value-added products that have been built through different research and innovation projects, through Copernicus land monitoring services, and through ESA thematic exploitation platforms. We have to tune them all for the raw materials, of course. Next slide, please. This platform could have high-resolution services and products derived from satellite, airborne, or in-situ data under subscription, like with a fee. This would be a set of products that are very localized, high resolution, for example, for mineral mapping at the regional scale or target definition at local scale, monitoring mineral extraction volumes and stockpiling, or monitoring ground stability in active mining areas. This is more complicated. On the other hand, the platform could have a pre-processed optical radar data layer for free derived from the Sentinel satellites, such as I was explaining before, the map of secondary raw material sources, mining waste areas and urban landfills, the map of ground instabilities in abandoned mining areas, or maps in specific countries of illegal mining activities, as well as the standards and the capacity building elements. Next slide, please. As Zoltan was saying before, we are trying to implement a pilot of this platform for Ukraine. We are doing this in the context of the partnership between Ukraine and the EU on raw materials. This partnership started in June last year, and one of the actions in the roadmap of this partnership was to develop a pilot of this platform. We are now trying to collect interest on the stakeholders of the space of the Earth observation community, Ukraine and the EU, to develop this platform through a mature project that can be presented to the European investment banks. So this is all. Thank you very much.
Thank you very much, Gerardo. That was very useful, and I think it started to give a flavor of really what this platform could address and what it could do, and I think it sounds very exciting to me. We did have one question that had come in but I suspect it came before your last slide because it was specifically asking about where you saw the main areas of policy relevant use of Earth observation outside of the European Union as far as our own kind of investments and developments. I don't know, do you want to say anything maybe a bit more on this? You know, would the platform kind of equally focus on both EU use of Earth observation and non-EU as far as developing international partnerships, or where do you see the kind of the balance between those two?
Yeah, well, very good question. Thank you very much. I will comment on that. So we have this opportunity that we are developing these international partnerships with resource-rich countries to develop mining in a responsible and sustainable way. And this is why we think that this platform can be useful to develop sustainable mining. So we have done this partnership with Ukraine, and this is why we have included this as a pilot in Ukraine, but we can extend this idea of the platform to other countries with whom we are trying to develop partnerships. This is the case, for example, from some countries in Africa or with countries in Latin America, where we are already developing a project on partnerships on raw materials. So I think this is about using this technological capacity of Europe to do policy developments in the sense of the raw materials for the international partnerships. Yeah. Thank you very much.
Excellent. Thank you very much, Gerardo. Very good. So now I suggest we move straight on to our next speaker. And in this case, it's a pleasure for me to introduce Richard Gilmore from the European Commission. Richard is in DG DEFIS in the Earth Observation Unit, where he's a policy officer, and he's involved in many different areas of the implementation of the environmental services for Copernicus. But perhaps most importantly for me, he's also basically my counterpart in as we've started to establish this new knowledge center on Earth observation, and he'll be telling us a bit about our ambitions, let's say, in the context of the work of that knowledge center going forward. Richard, you have the floor.
Thank you, Mark. Good morning, everybody. I hope the sound is fine and the video is working fine. I'd like to thank the organizers of the Raw Materials Week for giving us this opportunity to say something about the Knowledge Center for Earth Observation. So my name is Richard Gilmore. I'm working in the Earth Observation Unit in DG DEFIS. I think it's important to underline right from the start that the KCO is actually a joint initiative of DG DEFIS and JRC. So this presentation has been co-prepared with my JRC counterparts. So Mark Dowell, as he just mentioned, Andrea Camilla, and also my colleague Francesca Sommer, also from the Earth Observation Unit in DG DEFIS. So what I want to talk about in this short presentation is the setting up of the KCO, how the KCO works, and then I'd like to finish with talking about some specific benefits for the raw materials community, which have already to a certain extent been mentioned in the previous presentations. So before I see the next slide is already up there. So before looking at the Knowledge Center on Earth Observation itself, I would just like to quickly recall what a Knowledge Center is. So it is a relatively new concept. It was defined in 2016. It is a commission instrument that can be described as a virtual entity bringing together expertise inside the commission, but also from outside the commission. So it's a kind of a one-stop shop for the policy DGs with an interest in a given area. It is typically co-led by DGJRC together with one lead policy DG. And there are currently 8 knowledge centers in existence, and the most recent of which is the Knowledge Center for Earth Observation, which was launched just earlier this year. So what is the common denominator between all of these knowledge centers? Well, they all represent multifaceted policy areas with implications across numerous DGs. So for further reading, you can see a reference to the communication that formed the basis of the setting up of the knowledge centers. Next slide, please. So regarding specifically the Knowledge Center for Earth Observation, we can have a look at the rationale behind its creation. Firstly, we can refer back to the 2016 Space Strategy for Europe. This clearly underlined that Copernicus should support EU policies. It also insisted on the need for a coordination mechanism inside the Commission to ensure support to EU policies and political priorities. Furthermore, it also underlined the need to ensure that EO investments remained responsive to policy needs. Next slide, please. We can also refer to a couple of JRC studies, one from 2016 and another more recently from 2019. Both of these analyzed the current and potential use of EU Copernicus for policies within the European Commission. One of the main conclusions of these studies is that there has been a significant increase, not only in the awareness of Copernicus, but the actual use in support of policies. The reports also provided a mapping of DGs and policy units having an interest. And this, in the end, confirmed that there are numerous DGs having a direct interest in Earth observation. We identified at that time, in fact, 33 individual units in the Commission, these spread across 17 separate DGs. So this was one of the factors that led us to the conclusion that Copernicus and Earth observation more generally had reached a certain level of demand and awareness across many parts of the Commission, and that it now made sense to create a dedicated knowledge center for Earth observation. Next slide, please. So based on these studies, we also tried to understand the interest of the different policy DGs across different major policy areas. And what you can see in this graphic was that it was clear that for almost any major policy area, typically several DGs had an interest, and in some cases up to 7 or 8 DGs with an interest in a given area. Examples of such areas are biodiversity, SDGs, and water management. Again, this highlighted that it made sense to develop a mechanism to harness the synergies for the use of Earth observation within a given policy area. Another detail that emerged from the follow-up of these studies was anecdotal feedback that there were actually many more DGs having a potential interest for Earth observation than had initially been identified in these studies. So DGs, for example, such as EAC, TRADE, TAXUD, FISMA, OLAF, DIGIT, SecGen, NEAR, and COM. So these are some of the additional DGs that we realized also had an interest. We also understood that certain horizontal DGs, such as DG COM, had a strong interest to be involved in the KCO because of the significant communication potential of a European success story such as Copernicus. Next slide, please. So here I would like to move on to some of the more practical aspects of the setting up of the KCO. And here are some of the major milestones moving towards its actual launch. So in early 2020, DEFIS and JRC agreed that Earth observation was a transversal area suited to the knowledge center approach. And DEFIS formally requested that JRC co-develop the KCO. Over the course of 2020, there were also some informal consultations with potential stakeholder DGs to assess their interest. And the outcome of these consultations were all very positive. We therefore went ahead with setting up the KCO and the formal launch event was held in April 2021, actually during the Space Week, to announce this launch. And then the first meeting of the KCO's steering committee took place just before the summer break. One of the first outcomes of the KCO steering committee was to identify biodiversity as one of the best candidates for one of the first policy areas to be addressed. And I will come back to that in a later slide. Next slide, please. So a few words about the concrete aims of the KCO and how it will operate. The KCO has been set up to address two main pillars. The first pillar is to enhance the support of Earth observation to EU policy. And this includes increasing uptake, but it also will address gathering of needs and translating these needs into technical Earth observation product requirements. The second pillar relates to analyzing and prioritizing research needs. This activity should lead to recommendations for a strategy for future research investments. As I already said, the focus of the KCO is on the policy DGs of the Commission, but it will also be open to interfacing with external partners. One of the aims of such an interface would be to give cross-DG visibility of ongoing initiatives with major partners such as ESA and other Copernicus partners. Next slide, please. Now, a few words about the main components for the implementation of the KCO. So it will consist of a steering committee with representation from all relevant services of the European Commission. It is foreseen that the steering committee will meet probably once or maybe twice a year to define the main priorities of the KCO. The bulk of the work of the KCO will take place through working groups, addressing the core activities of the KCO and with the involvement of both Commission services and, as necessary, external stakeholders such as the entrusted entities and Copernicus partners. So the working groups will address, on the one hand, deep dive assessments of EO needs for specific policy areas and the translation of those needs into quantitative requirements, and also address that through working groups on aspects related to research and innovation priorities for EO. And as I mentioned earlier, it's also foreseen to provide opportunities for dialogue with the broader EO community and users on the work of the KCO. So that could take the form of, for example, public workshops or conferences. Next slide, please. Another aspect I would like to highlight is how the KCO will fit in with the existing activities and entities already working on Copernicus uptake and outreach. Over the last 6 years, the Copernicus program has developed several mechanisms to support uptake, dissemination, and coordination. This includes groups within the Commission, such as the Copernicus User Forum or other Commission-led uptake activities such as the Copernicus Academy and the Copernicus Relays. It also includes mechanisms outside the Commission, such as uptake activities run by the Copernicus services themselves and Copernicus partners such as ESA and EUMETSAT. These existing uptake support mechanisms are schematically represented in the circle on the left. Nevertheless, as I underlined in the introduction, there is a will to take further steps to improve the uptake of Copernicus. Several new initiatives have thus been developed under the new MFF. One of these is the creation of EUSPA. So what was called previously GSA has now evolved into EUSPA. It has an expanded mandate and new responsibilities, in particular now covering Copernicus. its focus is on the development of downstream markets and leveraging synergies between Copernicus and Galileo. Then, of course, the KCO. The KCO is also a response to the political desire for increased uptake of EO and Copernicus. And as already explained, its primary focus is inside the Commission with the policy DGs. To complete the picture, we should also mention Cassini. This is another new initiative in support of the space sector, which is mainly aimed at supporting innovative actions in the space industry, and will also cover some outreach activities in addition. I think the point I want to make with this slide is that the KCO is designed to fit into this existing landscape and is focused on the uptake of EO within the Commission to optimize EU policy support. Next slide, please. So I think I'm approaching the end of the available time, so I'll try to be very quick with this slide. I think the main point here is that we've established a taxonomy of policy areas. This is one of the first things that we looked at in the KCO. So maybe just one thing I can highlight in this slide is that raw materials has been identified as a policy area in its own right. So I think this is obviously an important point to highlight today, as this will ensure the visibility of the raw materials topic in the KCO's future work. Next slide, please. I think we can skip that. I already mentioned these items already. I'd like to just skip to the last couple of slides to conclude. So if you could put the next slide up. So I just wanted to say something more specifically about the benefits of the KCO for the raw materials community. I think what is clear is that Earth observation and Copernicus can be highly beneficial for the raw materials sector, and we already heard in the previous presentations a number of examples of that. In particular, the action plan for critical raw materials underlines that out of the 10 actions it has defined, 3 of those could directly benefit directly from the uptake from Earth observation. Next slide, please. And this is my final slide. So I think in terms of Earth observation support to raw materials through Copernicus, as we already heard, some products are already available that can be used to support the mining industry, and in particular in relation to remote infrastructures, ground stability, and pollution development. And as we also heard, with the development of new EO capacities over the next few years, we can expect further improvements to existing products, as well as the introduction of new sensing techniques, such as hyperspectral imaging and thermal measurements. Copernicus is also supporting the development of the EORM platform. We already heard about that. But I'd like to highlight a few specific areas which I think the KCO can support directly. The first thing we can say is that the KCO will be an important forum to ensure the visibility of raw materials and the corresponding EO needs. It will also represent an interface to discuss the optimization and tailoring of the existing product portfolio to extract the full potential of this portfolio. The first planned deep dive on biodiversity will be of direct relevance to DG GROW and the question of sustainable and responsible mining, which we heard a lot about in the presentation of Gerardo. So I think to finish, the KCO soon will start first working groups to gather R&D needs, which will also be another opportunity for DG GROW to express some of its priorities. And maybe you could just put the last slide up with just the reference to the web site of the KCO for people who want to get more information on that. Thank you very much for your attention.
Thank you, Richard. Thanks very much. We did have one question that I think we may come back to anyway later on in the presentations after the break on if in looking at the policy needs, how do we kind of take into context the complementary use of Copernicus data together with private sector data, and we heard some of that already before. So maybe we'll leave that for now, Richard, due to time, and come back to this in discussions after some of the other presentations later. But let's remember that that question was made. So we're going to transition now on to the last presentation before the break, which is from Patrick Nadel from EIT Raw Materials, where he's a senior advisor for exploration and resource assessment. Patrick, you have the floor.
Thank you very much, Mark. Yes. So today I will speak about RawMatCop and how to build skills and capacity at the intersection of Earth observation and raw materials. We have already heard from the previous speakers that RawMatCop and the Raw Materials Academy is an integral part of this newly developed Earth observation raw materials platform, and also this knowledge center for Earth observation. So it's really that segment, that kind of puzzle piece that I want to focus in on in my presentation here. Next slide, please. What I could also have called this talk is the RawMatCop success story. And actually at this stage, I really want to acknowledge two people in particular. It might be me giving the presentation now, but it's really up to two people that really on the EIT raw materials side pushed this RawMatCop project, and that's Irina Benito Rodriguez, who you will hear from later in the session, and also Eliane Furuyama. It's only people that make those tools and those technical advances that we always talk about work in practice. And that's one important point that I want to make here in my presentation. Next slide, please. It's really down to people, really, to build those capacities. And before I will go into detail about RawMatCop and the RawMatCop Academy, I just want to give you a little bit of background about what we at EIT Raw Materials, how we see the raw materials sector and how Earth observation comes into this field. We already heard a lot about that. I think the integral the key point here is that it's all about integrating the different technologies that we have available to connect the data that we collect along the entire value chain, from exploration to mining, processing, and all the way to recycling. And Earth observation can obviously be a very integral part in this. Next slide, please. Especially when we talk about not just this monitoring activities, but also, and that's a term that hasn't been mentioned yet in the context of Earth observation and raw materials sector, when we talk about transparency and social license to operate artisanal and small-scale mining, obviously, and those standards that we need to have in place when we talk about responsible mining and responsible supply chains. That's also very important. Next slide, please. So about the project that has been running for some time now. It started in 2018, a 4-year project, and it says there in the headline 2018 to 2021 and beyond. That is because the RawMatCop Academy is actually an ongoing activity. The RawMatCop program that was initiated and co-funded by EIT Raw Materials, DG GROW, and DG DeFis as finished, but we are continuing with this capacity building. And this is really the central point here that I want to make in my presentation. It's about the people that we bring in, and that's not just the researchers that actually help with this project directly, that advance the research in that field, and then also directly connected to end users in that RawMatCop activity and that academy that we have run for the last few years successfully, by the way, commercially successfully, I might add here. So this is can really be the central building block of this Earth observation raw materials platform and the knowledge platform that we have been talking about Next slide, please. So it's really about connecting, again, the different users, connecting the supply chains, where we collect data from different areas, exploration, I mentioned, all the way to recycling, post-mining activities, and so on, and to connect the postdoc researchers that were partly funded through this project, and bring end users from all different backgrounds, from all different stakeholder organizations, including industry, academia, startups, research and technology organizations, and so on, into this to build the capacities that we need to actually apply those new technologies and smart solutions that we have developed over the last years. There's so much possible already with the technology out there, but it's really about making those connections and building the capacity, having the skilled people out there that can actually apply all this out in the field. Next slide, please. So this is essentially the RawMetCop Academy in a nutshell. And the last one, actually, I already said, it's still running. The last one took place just earlier this year, and it is financially successful, and we very much would like to continue the success. Next slide, please. So this academy, as I said, has been running, and the key point I want to make here is that it is COVID-proof. So in this time, we are obviously all aware of the situation. It's critical for so many programs and activities to transition to this online space, and that's a real challenge. And it's specifically a challenge when you talk about something like Earth observation, where you have to deal with terabytes or large amounts of data, but we have successfully managed that. Again, acknowledging my former colleagues who have done that, and it's a really great course now that we can deliver online and have been delivering online. And this is not just a course that we've successfully been running. It's also actually now certified by the European Federation of Geologists. So a true success case, I would say. Next slide, please. Coming back to the case studies, I will not dwell on that too much because we already heard many examples, and it was really exciting to hear Zoltan talk about those new capabilities and what's possible nowadays. And that's, again, that's a key point here, because with this RawMetCop Academy, we really make that connection, the latest leading edge technology and solution, and we bring that to the actual end user. And we teach them how to use the technology, how to access Copernicus data, what to do with it, and to really get the most out of their data, and to really train people in how to apply all those amazing smart solutions that are out there, including mineral exploration, mapping deposits, monitoring, obviously, of mining activities, including the waste management, and environmental monitoring has been mentioned already, water detection, and other examples could be mentioned here as well. Next slide, please. So as I said, the target audience is not just the large industry and the managers and R&D officers. It's also the technology providers, startups and entrepreneurs, but also researchers, research organizations, governmental organizations, even NGOs, because it's also a point I made earlier. It's about transparency, having data available. You cannot control, monitor, or regulate what you cannot see. So it's really important to have this freely available and very cost-efficient data source that we have here with Copernicus, and use it to its maximum potential. At the moment, the course capacity is around at 40 people. We have done that online and in person. And it's obviously something that we would like to expand on in the future. Next slide. So into the applications. Next slide, please. And again, I will just quickly go through that, being mindful of the time here. So we really have examples along the entire supply chain, from exploration, extraction, again, to post-mining and recycling. Those are real examples of projects that have been driven by researchers and have been taught, excuse me, in our RawMet Corp Academy course. Next slide, please. So one example, I will just give 3 very brief examples here, is open pit stability, slope stability. Obviously, this needs to be monitored. We have seen a super pit there, Kalgoorlie, at the beginning, and to monitor these massive open pit mines and to monitor slope stability of those open pit mines, and also tailing dams, for example, is one specific application. Next slide, please. Specific applications, I might add, that are driven by our researchers, and you can see at the bottom right there, Elsie Ibrahim, for example, one of those researchers we had in the RawMet Corp Academy, and they're not just doing the research, they're also teaching the classes. So it's people, experts in the field that really are, presenting those leading edge solutions. Here, for example, I mentioned already artisanal small scale mining, informal mining, and how to detect it and regulate it. So what you cannot see, you cannot regulate. That point again. Next slide, please. And of course, exploring remote areas. One prime example here is obviously Greenland, and to cover those large areas, Earth observation, satellite data is the most cost-efficient way. Specifically, we already heard that specific capabilities will be added, such as hyperspectral data, that will make it even more interesting for explorers to go out there and use this technology. Next slide, please. My second to last slide, and again, I want to acknowledge the people that have actually been driving this, and this here is a paper by the researchers that were in this project, and Irene Benito, something that you should have a look at, a very good paper summarizing the activities, and again, this is something where we really see this outreach and connecting beyond the research community. Next slide, please. So you have heard a lot from me, and you already heard that it's actually certified course, the RawMet Corp Academy. But here's someone from the outside, an external opinion, and Pavlos is saying, I found that the course was very rich in content, and I also met great people with different backgrounds. You can read the rest on your own. It's really the point here is that it's a fantastic course, and we've heard so many positive responses from people that participated, from people that taught in those courses, including myself. I was able to give a couple of presentations there. It's a fantastic activity, and we should really keep it going. Next slide, please. As part of this Earth observation raw materials platform, and with that, I would like to finish my presentation and just say, yeah, we're ready for action, and we're ready to actively engage in this platform with you. Thank you very much.
Thank you very much, Patrick. That was very good and gives us I think a very key, addresses a very key element, which is developing capacity, of course, to make use of this. One question that came in was, we heard before when Richard's presentation about some of the other mechanisms that exist within Copernicus, and one of those, of course, is the Copernicus Academies, which provides networks of universities and research organizations, sometimes within a member state, in a couple of cases across member states. But is there any link between RawMet Corp and the Copernicus Academies, or do you see any potential for linking them, maybe to reach out to broader communities at the member state level? I don't know if you have any thoughts on that. Thanks.
Yes, thank you, Mark. My colleagues will probably be better placed to answer this question, but yes, there are, of course, links across using our own EIT Raw Materials Network and also the increasing European Raw Materials Alliance network with many of those universities that are engaged here. And we have those researchers directly being an integral part of this activity, of this capacity building exercise. And we also very much look forward to engage more closely in the future with member states on this. And also Ukraine was mentioned. This is obviously something where capacity building activities such as the ROMICOP Academy can really help to take action and to really make this happen.
Excellent. Thanks very much. And I saw that Irene has written in the chat that they are in fact already affiliated to the Copernicus Academy, so that's great. Okay, well, thank you very much to all of the speakers in this morning's, or in the first part of this session before the break. We're now going to take a break until 11:45 Central European time. So I'm afraid we lost 5 minutes of that break, but hopefully that will be acceptable. I would remind all of the audience online that the Slido is still open for your questions, but also for this word poll. There have been a couple of answers, but we really want to encourage you to do that. It will give us a nice visual overview of your thoughts on the use of Earth observation for raw material. And we're going to leave that open for the remainder of the session, and then we'll show it at the end of the workshop today. So thanks to everyone, both the presenters and those who have been following, and we'll see you all back here at 11:45 Central European time. Thank you.
Waste from electronic products, e-waste, is one of the fastest growing waste streams in the world, with almost 54 million tonnes generated in 2019, rising to 74 million tonnes by 2030, with less than 1/5 of this officially collected for recycling. These issues need addressing, not only to increase recycling, but to prevent e-waste in the first place.
The C-Service project has been created to tackle this challenge by developing electronic products that are designed to be produced, transported and consumed in new circular ways. The project focuses on 4 products: washing machines, televisions, printers and sensors that monitor network connections. It has developed new business models for each of them that reflect the circular economy concept.
The goal is to design products that last longer and contain a greater quantity of recycled materials, make it possible to lease the products rather than buy them, use 3D printed parts for repair or upgrade, improve the recyclability of the products, and take into account the social impacts of producing and consuming the products.
All this will be supported by an IT system that enables the tracking of products over their lifetime and gives easy access to information about them, such as the materials it contains. These innovations and principles have been applied to the products and are being rigorously assessed to establish their applicability and impact.
The outcome of C-Service will be 4 practical circular business models that have been implemented and tested, address all aspects of the life cycle of the products, and, crucially, will be able to be used by other manufacturers and for other products across the world. Join with us in achieving our goal. Visit cserviceproject.eu to find out more.
Minerals are present in the many products we use in our everyday life, and modern societies use a large number of mineral raw materials. Public opposition to mining, alongside barriers on the access to deposits, have been limiting the extraction of minerals in Europe, despite the existence of important mineral resources. For this reason, Europe is now highly dependent on imports of many different mineral raw materials used in critical sectors such as electronics, renewable energy and defense, and conventional mining offers no solution to tackle this problem. The Horizon 2020 project, RoboMiners, is unlocking the full potential of minerals supply from domestic resources within the European Union by making mining sustainable and invisible. Wait, but how? RoboMiners is developing a bio-inspired, modular and reconfigurable robot miner for small and difficult-to-access deposits. The robot will be able to mine underground, underwater and in slurries. Furthermore, it will be capable of sensing the ore and excavating it selectively. Are you curious about the robot miner's final design? Join us on our journey. Check out our website and follow us on our social media channels.
Why do we need minerals? Minerals are beautiful, but what's more, they are important for our lives. Virtually every single thing we use is taken from a mine somewhere on Earth. We might not realize it, but every single one of us is dependent on mineral resources. Why are they important? Without these raw materials, we would be forced to live lives that resemble those of our ancient ancestors. No phones, no fridges, no cars, no spaceships. Most of our buildings, such as schools, hospitals, offices, shops, and of course our homes, are constructed from mineral products. Today, newly constructed buildings must use materials and designs that are more energy efficient. When we start today, we need minerals from the early morning. Most toothpaste produced today includes fluoride, which helps remineralize tooth enamel, strengthening teeth against cavities, keeping our smiles beautiful and healthy. Every kitchen in Europe has at least some stainless steel cookware. Typically, stainless steel kitchen cookware also contains chromium and nickel. Salt. We might not notice it's there, but we sure would notice if it wasn't. In addition to containing sodium chloride, most table salt also contains iodine that helps maintain a healthy thyroid. We need a whole range of minerals for our glasses, plates, and cutlery. Quartz sand is used from everyday glasses to high-quality manufactured glassware. Porcelain is largely made of the clay mineral kaolinite, and this is usually mixed with other materials such as feldspar, steatite, quartz, or other clays. For your forks and knives, we need steel, chromium, and nickel. When strengthening your immunity, our bodies need a wide variety of minerals to work properly. Iron helps oxygen get from the lungs to other parts of the body. Calcium helps bones grow strong. Chromium aids in insulin function. Copper contributes to bone health as well as nerve health. Each mineral plays an important part in maintaining a healthy body. Summer days are wonderful, but the skin needs protection. That's why sunscreen is an essential tool in homes across Europe for protecting our skin from the damaging rays of the sun. Sunscreens with high physical UV blockers almost always contain titanium dioxide, zinc oxide, or both. When saving for your favorite treat, those coins sitting in your pocket, purse, or piggy bank are made of specific combinations of metals to give them hypoallergenic and antifungal properties. They are a mixture of copper, aluminium, zinc, and tin. When going to the places you need to be, bicycles offer one of the most eco-friendly modes of transportation, and biking is also good for your health. In the past, bike frames were mainly made out of steel, but today more lightweight materials are used, such as aluminium or even carbon. Cars are complex machines that require a huge number of parts to work together. For production of these parts, we need a whole range of metals and minerals. When discovering new things, a mineral raw material can be an element, mineral, or rock, which is part of the Earth's crust. It can serve to meet the needs of society directly or through technological modification. In other words, mineral raw materials are those minerals or rocks that are used to obtain useful elements or compounds. Experts help us ensure that minerals are not imported from conflict zones outside Europe, where the human rights of the workers involved are not respected. By nature, mining is a temporary use of land. The innovative new uses of old mines across Europe occur in amazing frequency and with a vast range of purposes. In some sites, you can explore amazing geological history. It's difficult to list all the raw materials needed for a mobile phone. One phone contains over 50 different minerals and metals, each specifically used to achieve a communication or entertainment function. But to name just some of the materials needed, indium and yttrium enable touchscreen technology, neodymium and dysprosium are used in speaker and microphone systems, and printed wiring uses copper, tantalum, tungsten, silver, and gold. When producing our food, when we imagine fresh vegetables, mineral mining is not the first thing that comes to mind. But plants need nutrients to grow, and nutrients come from fertilizers, and fertilizers come from minerals. Fertilizers that help produce a good harvest are made from potash, phosphate rock, calcium, magnesium, sulfur, zinc, and nitrogen. We need good food, and our food needs mining. When having fun, you will find a lithium-ion battery in many devices used daily, from computer tablets to toys. Lithium is used for rechargeable batteries and all portable communication disk drives and microchips, for example, in your phone or camera. You can use clay to make your own pottery, and you will find clay minerals all around you, from the tableware in your dining room to the sanitary ware in your bathroom. Aluminium is omnipresent and we use it almost everywhere. All of us know the aluminium foil we use to wrap our sandwiches when going for a picnic or for baking in our kitchen. But its unique properties also make it ideal for the construction of vehicles and aircrafts. Metals and minerals are used for many musical instruments. Did you know that the strings of a piano are made from a special high-tensile carbon steel wire? When working on a school project, as most people know, pure silicon is a significant part of a computer chip. But inside all digital technology, you can also find aluminium, magnesium, and zinc. Additionally, computer chips may contain phosphorus, boron, gallium, aluminium, or quartz, and many computers use precious metals such as gold, silver, and platinum. Today, computers are standard tools for European school kids. As with all electronics, computers contain printed circuit boards, or PCBs, that are mainly made of copper, but may also include tin, nickel, or even gold. When making our life more beautiful, the jewelry that we bedazzle ourselves with contains a wide variety of minerals and metals. Precious metals like gold, silver, and platinum have been used for centuries. LED bulbs are the most efficient form of electric lighting available. The larger parts of an LED bulb are made of metals such as nickel and copper, but the distinguishing parts that make a bulb LED are rare earth elements. To write with a pencil, we use a mixture of graphite and clay. Kaolin is necessary for all kinds of paper. Metals and minerals are a part of our daily lives.
Since the beginning of 2020, Lithion has been operating a demonstration plant in Anjou, Canada, to pursue the development of its recycling technology at industrial scale. The patented process developed by Lithion accepts all types of lithium-ion batteries regardless of its application, chemistry, or state of health. Once the battery has been dismantled to module size, it is sent to the first portion of the process, the spoke. This size reduction and separation step neutralizes the battery in an efficient and safe way and separates the black mass from the copper, aluminum, iron, and plastic flakes. The black mass contains all the critical and strategic minerals necessary to produce batteries. But before it can serve directly the battery supply chain, it needs further separation and purification steps. Therefore, the black mass is sent to Lithium's hub, a hydrometallurgy-based process. There, the black mass is put in solution with sulfuric acid by leaching. Lithium's first battery-grade product, graphite, will be harvested after this step. Through subsequent steps of purification and extraction, nickel, manganese, cobalt, and lithium will also be extracted and purified to finish as battery-grade materials. This means they are in the right form and their purity is high enough to be returned to battery manufacturers. Lithium's overall process recovers 95% of the battery components from lithium-ion batteries. Its technology closes the loop on the battery life cycle and is the most sustainable solution today to face the millions of tons of batteries coming to end of life in the next decade.
We all want to live more sustainably. But did you know that much of the technology we use every day contains materials that have potential issues with their supply? These are known as critical raw materials, and many of them have special properties that make them crucial to the technology we rely on today and will continue to rely on in the future. So, in order to make the supply of these less of a risk, the European Union's plan is to increase the amount we reuse and recycle from our waste. The problem is, recycling of most critical raw materials is not commercially viable, and current standards for collecting and processing waste that contains them don't address their recovery. So, what can be done to help? The Sea Waste Project has identified the gaps in existing standards and has developed a new and improved certification scheme for the collection, transport, waste processing, and recycling of this waste, focusing on 4 key components that are rich in critical raw materials. The new sea waste requirements have been tested in the real world to check the suitability and impact of the scheme. The project has also developed tools to audit compliance with these requirements in the future. Adopting the certification scheme, together with the creation of wider financial incentives and a conducive legal framework, will encourage the investment needed to make recycling critical raw materials more commercially viable in Europe, helping us become less reliant on existing sources. This is why the Sea Waste Project is demanding that its certification scheme be made mandatory across Europe by the European Commission. A united approach from industry is also needed, as the standards will only work when there is widespread adoption. It's a chance for Europe to help drive the world's green agenda, while at the same time creating new business opportunities at home. So, if you want our society to be more sustainable by recycling more of its critical raw materials, you can join with us in adopting and promoting the Sea Waste Certification Scheme and driving change in policy and industry.
Waste from electronic products, e-waste, is one of the fastest growing waste streams in the world, with almost 54 million tonnes generated in 2019, rising to 74 million tonnes by 2030, with less than 1/5 of this officially collected for recycling. These issues need addressing, not only to increase recycling, but to prevent e-waste in the first place.
The C-Service project has been created to tackle this challenge by developing electronic products that are designed to be produced, transported and consumed in new circular ways. The project focuses on 4 products: washing machines, televisions, printers and sensors that monitor network connections. It has developed new business models for each of them that reflect the circular economy concept.
The goal is to design products that last longer and contain a greater quantity of recycled materials. Make it possible to lease the products rather than buy them. Use 3D printed parts for repair or upgrade. Improve the recyclability of the products. And take into account the social impacts of producing and consuming the products.
All this will be supported by an IT system that enables the tracking of products over their lifetime and gives easy access to information about them, such as the materials it contains. These innovations and principles have been applied to the products and are being rigorously assessed to establish their applicability and impact.
The outcome of C-Service will be 4 practical circular business models that have been implemented and tested, address all aspects of the life cycle of the products, and, crucially, will be able to be used by other manufacturers and for other products across the world. Join with us in achieving our goal. Visit cserviceproject.eu to find out more.
Minerals are present in the many products we use in our everyday life, and modern societies use a large number of mineral raw materials. Public opposition to mining, alongside barriers on the access to deposits, have been limiting the extraction of minerals in Europe, despite the existence of important mineral resources. For this reason, Europe is now highly dependent on imports of many different mineral raw materials used in critical sectors such as electronics, renewable energy and defense, and conventional mining offers no solution to tackle this problem. The Horizon 2020 project, RoboMiners, is unlocking the full potential of minerals supply from domestic resources within the European Union by making mining sustainable and invisible. Wait, but how? RoboMiners is developing a bio-inspired, modular and reconfigurable robot miner for small and difficult to access deposits. The robot will be able to mine underground, underwater and in slurries. Furthermore, it will be capable of sensing the ore and excavating it selectively. Are you curious about the robot miner's final design? Join us on our journey. Check out our website and follow us on our social media channels.
Why do we need minerals? Minerals are beautiful, but what's more, they are important for our lives. Virtually every single thing we use is taken from a mine somewhere on Earth. We might not realize it, but every single one of us is dependent on mineral resources. Why are they important? Without these raw materials, we would be forced to live lives that resemble those of our ancient ancestors. No phones, no fridges, no cars, no spaceships. Most of our buildings, such as schools, hospitals, offices, shops, and of course our homes, are constructed from mineral products. Today, newly constructed buildings must use materials and designs that are more energy efficient. When we start today, we need minerals from the early morning. Most toothpaste produced today includes fluoride, which helps remineralize tooth enamel, strengthening teeth against cavities, keeping our smiles beautiful and healthy. Every kitchen in Europe has at least some stainless steel cookware. Typically, stainless steel kitchen cookware also contains chromium and nickel. Salt. We might not notice it's there, but we sure would notice if it wasn't. In addition to containing sodium chloride, most table salt also contains iodine that helps maintain a healthy thyroid. We need a whole range of minerals for our glasses, plates, and cutlery. Quartz sand is used from everyday glasses to high-quality manufactured glassware. Porcelain is largely made of the clay mineral kaolinite, and this is usually mixed with other materials such as feldspar, steatite, quartz, or other clays. For your forks and knives, we need steel, chromium, and nickel. When strength
Good morning and welcome back to all. I hope you had a good break. We're continuing now with this dedicated session today, looking towards a platform for raw materials. And we have another 3 speakers in this part of the session. I'd remind everyone again that we have a Slido word cloud open. If you can express your opinions on what products and services are important for raw materials there, that would be useful. So we're going to start this session with a presentation by Maxime Lemaire, who is a remote sensing engineer at Sentinel Hub GmbH. And I suspect Maxime is going to start to address some of the issues on how we deal with big data in the cloud, and in particular looking at raw material applications and data cubes. So Maxime, you have the floor.
Yes, thank you. Yes, first of all, I'd like to thank ESA for giving me the opportunity to present the Eurodata Cube to you today. I am going to start by presenting what the Eurodata Cube is as a big cloud computing platform and how it can support mining applications with a specific use case here, the H2020 GoldenEye project. If you can go to the next. So Eurodata Cube is currently an ESA-led project which is being developed by a consortium of leading industry partners, which include EOX, Brockman Consult, Synergize, Sentinel Hub, for which I'm working, GSAT, and some other partners. We're partnering up with data providers. So the Eurodata Cube is a platform that aims to provide a single online location where users can access all the tools that they need to bridge the gap between the large volumes of Earth observation data that we have access to nowadays and value-added information or insights that you can derive from this platform or for this data. So this platform is articulated around 3 major points. So the first one, next please, is data access. You have access to global archives of analysis-ready Earth observation data in a single place. So no matter what the source is, you don't have to go to different providers to access the data. Next, you have a cloud-based processing platform where you can perform your computation, develop your algorithms, and build up your workflows in the cloud, so close to the data. Next. And that includes building data cubes, which is, as we see it, the modern way of approaching the vast amounts of Earth observation data today. And lastly, next, you can share your data with other users or your algorithm on a common marketplace where you can collaborate. Next, please. So the way the Eurodata Cube is built, it's built on top of a layer of cloud-based data. So you have all the different providers. It could be from the Copernicus program, from the NASA programs, which have data in the cloud and that are served via a number of endpoints. These can be services such as AWS or the different dioceses. Next. On top of this sit the different data services from the Eurodata Cube. So as I mentioned before, the access services, which allow you to seamlessly access the data without any pre-processing via tools such as Sentinel Hub or Xcube. Next. The processing services, which allow you to develop cloud-based analysis workflows. Next. And the marketplace where you can share the data. And finally, if you can go to the next, all the services which are within the platform are accessible via a set of endpoints that you can share if you're developing applications or if you need to streamline the whole system within your workflows locally. So if we go to the next, please. Here I've listed the available data, so I'm not going to go through it in detail, but it's just to highlight that Eurodata Cube provides access to all the open, or most of the open Earth observation platforms, including data that goes back to 1972 with the Landsat programs. We offer access to radar data, but also have some partnerships with some very high resolution imagery providers, such as PlanetScope, Pléiades, Airbus, or Maxar. Next, please. We have a growing catalog of open data that's accessible via the Eurodata Cube. Through collections.eurodatacube.com, you can see the list of data that's being added to the platform, and this is a growing resource. Next. The way data is accessed in the Eurodata Cube is through Sentinel Hub services, which offer quite a simple way of accessing the data. You specify some input parameters and some output parameters through what we call a payload and an eval script. And then Sentinel Hub takes care of all the pre-processing for you. You don't have to think about downloading gigabytes of data anymore, doing any form of mosaicing, reprojection. You get the image directly injected into your workflow. And for large data sets, next, we use the Xcube technology, which allows you to build up data cubes. So let's see how this is being put into practice in the GoldenEye project. So GoldenEye is a H2020 project with the aim of developing a multi-source Earth observation data platform, which is based around 3 points: improving safety and operations through mine safety, the environmental footprint of the mines or profitability, monitoring of mining activities. So we do open pit slope stability mining, for example, or mine waste pile stability or tailing monitoring. And thirdly, by supporting the mineralogical mapping of sites or the analysis of the data for exploration or analysis of mine shafts. And the project is built around a cloud solution that allows mining customers and authorities to very easily extract information about mining sites. Next, please. The customer-facing interface of the GoldenEye project is GoldenAI. It's a platform which is designed to make remote sensing data processing easy and affordable for users. It integrates AI knowledge packs, which are a way of analyzing the data and producing value-added information about the Earth observation data, and that can be tailored to your use cases. So if today you're interested in looking at INSAR analysis to monitor very small displacements over your mining site, you would use the INSAR knowledge pack. Or in this case, with the Eurodata Cube, if you're using, say, Landsat data, you can have a dedicated knowledge pack for the analysis of that specific data flow. And these knowledge packs can be then added by different users within the platform. Next. Here's a data flow architecture. So the main way the GoldenAI platform works is that users are faced with a GUI and can make requests in natural language. Then an artificial intelligence layer based on IBM Watson will understand these natural language commands, fetch the correct data flow from, for example, the Eurodata Cube, or query a specific knowledge pack to provide the information which is generated by different consortium partners. The data analysis will be performed and value-added information will be served to the client via this graphical user interface. So next. So in the case of the data which is fueled through the Eurodata Cube, we can take Landsat 8, and currently within the scope of the Golden Eye project, we're working in Pyhäsalmi in Finland on a mining site. And upon request, the Golden AI platform will query data cubes of Landsat 8 images, so the raw bands of Landsat 8, integrate these cubes within the platform, and then in the background do some artificial intelligence-based processing. Here it will be some clustering, and then serve the results for analysis to the end users through a graphical user interface. To access this data, the users will just state a series of simple commands in the user interface box, such as show me the clustering of Landsat 8 data over Pyhäsalmi for 2020, and the system will understand this command and fetch the data on the fly from the Eurodata Cube and do the artificial processing on top of it. Next. This is, I'm not going to go into detail, but this is the workflow for the Landsat 8 data stream in Golden AI. As you can see, there's a specific knowledge pack. Then given some input parameters, so an area of interest and a time of interest, the data will be queried on the fly through the data cube. A stack of Earth observation data will be created, and this analysis-ready data will then be fed into the machine learning model to generate predictions for different clustering types and allow the visualization, and hence the publication of this visualization to the GUI. And for each different source of data, EO data, we'll have a specific knowledge pack, and the Golden AI platform will perform a specific workflow for the data that we would like to have generated. We have currently knowledge packs for data such as Landsat or Sentinel-2, which are optical data, but also for radar data. And then we also have provisions for doing INSAR analysis. And lastly, the last slide will be an overview of the graphical user interface of Golden AI, which should be available shortly to users. And you can go and have a look at the progress of the project on the website. You're faced with a map, as most Earth observation interfaces, and you have a certain number of modules. First of all, you have the module where you can perform your requests, as I mentioned, in natural language. Once the results are returned to you via the GUI, you can have a number of different tools which allow you to explore the data, either to dive through the data cube with some transparency tools, for example, or to compare different data sources. So all the information that's going to be computed within the GoldenEye project will be available in this one platform, which is fueled by different big data services such as the Eurodata Cube. That's it for me. On the next slide, I've listed a few resources where you can get more information about the Eurodata Cube or the GoldenEye project. So the GoldenEye project has a website here, but you can also follow or learn more about the Eurodata Cube on its website or through the classic social media networks. Thank you very much for your attention, and I welcome any questions.
Thank you very much, Maxime, for that. That was, I think, really building on some of the things we heard before, great, and showing very concrete applications and how through these kind of big data interfaces, we can really kind of get to the specific use of the data by specific users. And actually, we had a question which I think is probably related to the last slide or the last real slide you showed, which is, if in kind of engaging with the different communities, you've come up with any specific preferences on the user interface itself that are unique to that are particular, let's say, to the raw material user community. So are there specific requests or needs that have been expressed in your dialogue with the raw materials user community that on specific aspects of the user interface?
So I'd say one of the main points that we realized when talking to the people that are working in the raw materials industry is that they're not specialists in Earth observation data. And when us remote sensors start talking to them about the technicalities or what you can do with the data, they're quickly lost. So the idea of the platform is for people that don't have that knowledge to be able to focus on the information that they know is going to be useful for them, and actually access this added value information rather than have to deal with all the technical jargon and all the technicalities of Earth observation processing. We want to make an abstraction of this layer and offer them information that they'll understand immediately, which will then be able to be translated into actions for decision-making processes in the field. So this is really what we're trying to do here, is removing this layer of complexity of the Earth observation processing and offer the results and the value-added data in a format that people in the mining sector can understand.
Okay, thank you very much for that, Maxime. I think that makes perfect sense. So we're now going to transition on to our next speaker, which is Michael Foumelis from the University of Thessaloniki. And Michael is a geologist and geophysicist specializing in geodesy and geohazard, and is an assistant professor at the university. And I think that Michael is going to be telling us a bit about something we already heard from Zoltan about the thematic exploitation platforms for raw material. Michael, you have the floor.
Yes, good morning from my side. I hope you hear me well. First of all, I would like to thank you for the invitation to show this this development here in this meeting. I could use also what Maxime mentioned with different slides, so I can show exactly the same what he was talking about with my slides. I think there is a large overlap. I think a lot of people have understood that now there is a requirement for a way to process large data sets from satellites for different applications. So if we go to the next slide, I also need to mention here that I am also presenting this work, but behind me there is a lot of scientists, engineers, ESA technical officers that are working all together to make this happening. So I will start with this nice slide stolen from ESA, showing the development of satellites, although I'm missing all the latest satellite that we can put after 2030. In fact, here we have the green are the actual science satellite, the orange ones are meteorological ones. And in between, we have the Copernicus satellites, which were developed by ESA and the Commission. And I just want to mention why we went through having satellites which are becoming operational. And having operational satellite means practically that we have mature Earth observation techniques to use and to utilize all this information. So next slide, please. So I'm just showing here an example about the maturity of synthetic aperture radar interferometry in SAR techniques for monitoring terrain motion. And this started back from the first satellite that ESA launched back in 1992. There was the first demonstration of these techniques. Then it went through a lot of development, revolutionized at some point by University of Milan and other companies for measuring terrain motion at millimeter level. And now I think they reached maturity and validated the technique through different ESA, Terra Firma project and other projects that ensured that the techniques work. And we have also the Copernicus mission and different other national and commercial SAR mission, which are allowing us to move to operational services. On the right, you can see some graph on the download of data from all this Copernicus mission, from the annual report of Copernicus services. And you see that there are a lot of data here. So next slide, please. All this data were downloaded, and we want, as Maxime mentioned before, we want to move from the idea that someone downloads the data. So we have people requiring some information. We have scientists, practitioners of different thematic domains, and we offer them access to this satellite data and services. This idea came back in '92 during an ESA conference. And then ESA came with the idea of the thematic platform. And this is exactly what they are offering. There are different thematic exploitation platforms for different thematic domains. And I will discuss more, I will focus more today on the GeoHazard exploitation platform, initially designed to address the needs of volcano, seismic, and landslide community. Next slide, please. So what are the components that the platform needs? Platform needs data. I don't go now into details. You see that here we are storing and also linking to other resources, other data sources and data cubes, Sentinel data, Landsat, historical missions of ESA, as well as missions coming from CNES, Pleiad data, optical data. They are fully now integrated on the platform, and several other ideas. So next slide, please. Apart from data, we need the computing power. The computing power of the platform comes again from linking the platform, the interface of the platform, to different cloud providers, service providers for computing. This can come from DSS, this can come from Amazon Web Services, and so on. And what is missing? We have data, we have computing power. Next slide, please. We want the services themselves. So we have 25 on-demand services. Several of them also are systematic. They can be triggered based on event. So an earthquake happens somewhere and the service is automatically triggered to generate some results. There are services now being integrated at full resolution, optical and SAR analysis. We have also artificial intelligence services. We have automatic reporting, and also all this idea of having layers of information that people need to take decision and action upon them, and to make it easier for them and not bother them with all these technicalities of the Earth observation details. So next slide, please. So here we show different services for different domains. Of course, I told you before, we start with seismic, volcanoes, and landslides, subsidence. Services, we realize that many of these services can address also floods, fire, and many of them can be, of course, could be tuned for the raw material sectors. All the services that are monitoring changes in the surface, either it is height or motion or different changes in the surface of the Earth, can be used in the raw materials section. Next slide, please. So here I will focus on two main services for terrain motion. This one is coming from CNR IREA. It is called PSPAS. This has been there for almost more than a decade. It has been validated. This result is over Jakarta area. Next. So if you see, we can zoom. All these red spots are area motion. This can be run over mining areas, over other different domain to monitor the stability of tailings and so on. Next. And the user who is next. And the user can use all this data, for instance, to download them and to decide whether these layers will be private, will be shared with other e-collaboration community that he wants, or made public completely to the whole community. Next, please. Another service which has been recently integrated is the snapping service. Again, a terrain motion service which gives time series of measurement using the ESA Snap and STAMPS open source softwares. And it has been used not only for terrain motion, but for subsidence landslide, but also for earthquakes, and can be easily used for monitoring infrastructure and mining sites. Next, please. Apart from this is the interface of JEP. On the left, we have layers, data, and outputs. On the right side, we have the services. In the middle, we have the visualization of the results. Apart from the visualization that you have on the platform itself, next, please, you can have now also layers which are like files, simple GeoBrowser files that anyone that doesn't have a specialized software, for instance, QGIS or whatever other GIS software to visualize, he can use his GeoBrowser to visualize the result and investigate the analysis. Next slide, please. Another service is a suite of services for landslide app for terrain for motion using optical data. This has been developed by University of Strasbourg and CNRS. I will focus on these ones, not on the landslide detection part, but also on the digital surface model generation. Next slide, please. This uses Sentinel data and Pleiad data for very high resolution terrain digital elevation model generation, and this can be used for monitoring also changes, volume changes during raw materials storage or open mined activities. Next, please. This is just to say that all these results had been validated by the scientific community. So this is a result coming from the group of Geraldo back in Spain. They used this for monitoring some landslide, and also in the past, they used this activity for monitoring some mining sites. Next. But also we do some scientific work behind to validate these results. So we run over several sites services which are completely independent with the same data sets, and we show the robustness and the consistency of these results. This is over Haiti area. And next slide, please. Also, this is over through another ADB project. Next. Okay, I think we missed one slide, but this doesn't matter. So all these validated and robust now services has been used for the World Bank. This is for the City Resilience project. It was used as an entry-level products which are fully affordable in terms of cost to cover wide areas for the decision-making of the World Bank over several cities. So next, please. You will see some results coming from different cities. Next. This is Beara, Mozambique. Next one. Capaiten in Haiti. Next. Paramaribo. Next, please. Vienlong, they had a lot of problems. In fact, next. This you can visualize in the slide later on, and this is Yangon in Myanmar. Next, please. All these data come with different other visualization options to analyze the data to make the people understand much easier what are the data sets showing in terms of terrain motion. Next, please. And they were used also from the World Bank to investigate the hydrological effect of terrain motion over the area of Mexico. And you see now that processing over 175 kilometers was done, and you have a full-time series of the formation that can be visualized over this area. Next, please. And this is a case study also that we were asked to generate results very quickly for the West Africa State Report to show the stability of coastal area. And this processing was done within almost 1 day, 30 hours. 90,000 measurements was generated, 352 data sets were used. With a very short time, we were able to generate results to show the formation and terrain motion over all this coastal area in Dakar. And then I will close now by saying that platforms are offering us access to data. They have also giving us access to high accuracy and robust services. They are affordable. Of course, they can work together with industry and bespoke project services. They has been used by the World Bank and other demonstration with the Asian Developing Bank for offering these services to end users. You have cloud facilities that you can use and generate all these results in a more affordable way. And of course, you are anyone that I will ask, and I will invite people to install and integrate services on this platform, because in that way, maybe this platform can express also need of other domains like the raw materials. And all the people are, they remain the owners of the services, and they decide which services to be shared with which group, or they become completely public. Any information that you would like regarding the access of the services of JEP, you can send this email to the platform operators or send directly email to us. That was from my side. I think I am on time. Many thanks for that.
Thank you very much, Michael, for that. That was very good. I now understand that it was really an overview of the geohazard TEP, and I see a question coming in, which I'll turn to in a minute. Just to be clear, from my point of view, and you showed, of course, how it's relevant to raw materials as well, but in the future, do we see, and maybe this is a question to Zoltan as well, do you see the raw materials elements remaining kind of like a subcomponent of the geohazard TEP, or do you see it also maybe being a separate TEP in its own right? I don't know if that's for you to answer, or maybe Zoltan, but just out of curiosity.
So from my side, I think when you have a platform, you can integrate any services. Within the platform, you have also apps. So you can design apps within this to address specific need of specific society. So inside the geohazard exploitation platform, you have apps for the seismic community, you have apps for the landslide community, you have different apps, and there they are exposed to services more relevant to their needs. So a raw material app could be only part of the platform, and services can be integrated for this specific community. I think we can use and reuse already existing technology and don't invent things from scratch. Although now in the future, I'm sure there will be ways also to interconnect platforms between them. So this is already happening. So this could also be a case.
Okay. Thank you very much. And there's a specific question, if you could just answer very quickly, on whether there are any applications in the geohazard TEP, specifically looking at monitoring abandoned mining areas.
Yes, all the deformation, all the services which are focusing on terrain motion can be used. We have done these exercises before, and also you can use services not only for using SAR data, but using optical data as well to monitor the stockpile monitoring in terms of volume increase and surfaces. And also there are services which are very generic, which they offer only change detection approaches, which they can be used, of course, using high resolution optical data and high resolution SAR data to monitoring the activity or the changes over these mining sites.
Okay, thank you very much, Michael, and thanks for your presentation. So now we're coming to our last presentation in this morning's meeting. And this will be Irene Benito, who, and I think no better way to end this session than to have an evangelist, an Earth observation evangelist for raw materials. So that's definitely a good omen for our work together on the platform. And Irene is, in fact, the European Forum's Earth observation evangelist for raw materials, and she in promoting the uptake of Earth observation to make raw materials and industries more transparent. And she's also working at Planet as a senior product manager for marketing manager for government customers. So Irene is going to tell us about, from her perspective, building raw materials platform from the ground up, and the potential contribution from Earth observation companies. So Irene, you have the floor.
Thank you very much, Mark. Everyone can hear me, I hope. Thank you so much for inviting me to speak here today. I am speaking today, of course, as Earth Observation Evangelist for raw materials, but I think it's important also to highlight that I was working at EIT Raw Materials before, and just working on the uptake of Copernicus convinced me so much that I then made the switch to the Earth observation sector. So I'm thrilled really to be here today. Thank you. And yes, so today my presentation is going to be focusing on the raw materials, on the Earth Observation for Raw Materials platform, and really on the role that industry can have in this platform and how essential it is to make it successful. So next slide, please. Thank you. So for those that are not familiar, the European Forum for Earth Observation, or the FIRE Forum, is a Horizon 2020 project which aims to inform Horizon Europe planning for Earth observation in 6 key sectors. This is agriculture, energy, infrastructure, the maritime domain, raw materials, and urban developments. It does so by engaging with sectoral actors from each, of course, of these industries to understand their needs and also understand the potential that Earth observation can have, as well as looking at the barriers for adoption and seeing how to overcome them. These insights are then shared with the Commission for inclusion in Horizon Europe planning. And part of the project, of course, involves the Evangelist program, which is what I'm part of. And what we do is that we act as spokespersons for the Earth observation European sector in these targeted industries. Next slide, please. Perfect. So today, I will repeat some of what has been said today, especially in the first part. So I'm going to open talking about the stage of play where the European raw material sector finds itself today, and also then looking at the potential of Earth observation to face the challenges and the changes that the sector is undergoing. Then I will move to the platform, and there I'm going to talk about the enormous role that I believe the industry can play for the success of the platform, both upstream industry and of course downstream industry. Next slide, please. Okay, so starting the presentation, where is the European raw materials sector today? And this is not only the case of Europe, it's really globally. The sector is facing enormous change and enormous challenges. Patrick already covered some of this before, but we're facing growing demand for raw materials across the board. This is, of course, leading to the need for more remote and more deep exploration campaigns, as the low-hanging fruit and these more superficial deposits have been depleted, and also, of course, also to explore secondary materials. We also see there's growing price volatility with commodity prices fluctuating a lot, leading to risks to jobs, risks to growth, and also risks to security of supply in Europe. At the same time, the raw material sector, like many other, like all other industries really, is facing the challenge to adapt and embrace both the sustainability and the digital transformations that are undergoing, as well as we see an increasing growth in the importance of social license to operate, a growth in public scrutiny to the sector, and of course, increased demands for transparency in the sector, but also across global value chains. So also activities that are taking place outside of Europe. And I think in face of these challenges and in face of this change, we can with confidence say that Europe needs to become more resilient. If we want a stable supply of raw materials, if we want a prosperous future, and we want a successful transition to carbon neutrality by 2050, as identified, of course, by the Green Deal, we need to become more resilient and we need to become more autonomous. And this is already outlined, of course, in the 2020 Critical Raw Materials Action Plan. Next slide, please. And here's really where Earth observation comes into play. Earth observation can be game-changing, helping us face these challenges and really helping transform the industry. It can help boost competitiveness of the raw materials sector, and it can also help the sector embrace both the digital and the green transformations. And I think, like was said already before by Richard, it's not surprising, therefore, that Action 7 of the Critical Raw Materials Action Plan already talks about the deployment of Earth observation programs and remote sensing for more safe and sustainable mining. Next slide, please. And I know that Zoltan and Patrick showed actually applications and relevance of the technology across the whole value chain of raw materials. And I think this is because there's so many benefits of the technology. It can be used in complementarity with other sources of data, actually must be used in complementarity with other sources of data if we want to make the most out of its potential, especially with ground data for validation. The technology also offers the capacity to monitor both large areas. We have Sentinels like Sentinel-1 with a swath size of 250 kilometers. We can monitor not only large mining sites, but also large mining environments where we may be having, for example, environmental impacts, or we may be affecting urban developments. But then we can also have sub-meter resolution, actually under 50 centimeters at the moment, that can help us evaluate and assess small features like tailings or stockpiles where we may be, for example, interested in secondary extraction. We're also not only providing pictures, we're providing extremely valuable information from vegetation indices, information on soil moisture, hyperspectral data now with hundreds of spectral bands, of allowing us to much better engage in remote exploration campaigns in the mapping and the classification of these mineral deposits with much richer spectral libraries, spectral signature libraries, but also looking at issues such as air quality and soon being able to pinpoint source emitters. Also, the data, of course, is already is objective, is transparent, and is already in a digital format, which is extremely useful. And then finally, the data is providing us with really almost real-time information. We have constellations with hundreds of CubeSats orbiting the Earth and providing global and daily coverage. We also have rapid and intraday tasking capabilities. And with this, we can really see change as it happens, which can be essential for applications such as emergency response. After an accident takes place, we may want to immediately have information of what has gone on, and field deployments may not be feasible, but also just to make decision-making, operational decision-making more efficient, taking decisions really as change happens. Next slide, please. So I think we're all here today because we know the benefits, we know the potential, but clearly adoption is sluggish. And there are definitely several important barriers for adoption in the sector, and the ones presented in the slide have been identified after dialogue and interaction by the FIRE Forum with industry following the consultations. And I've identified in bold those that I think the platform can really contribute to. And before I look into them, I think it's essential that we understand the need to be able to translate these barriers into needs. And then we meet these needs with targeted solutions. And the platform has to be one of these. For example, the platform is essential that it provides, that is part of the wider efforts that I know the institutions and also actors such as myself are undergoing to really increase the understanding of the potential of Earth observation for mining, that we really make sure that the solutions provided by the platform are solutions and are not just raw data, that we provide information in a way that cannot be misinterpreted, that is clear, that it only has one interpretation in a way, that we are considerate with the sensitivity around a lot of mining of issues in mining operations, and also that we highlight the value of the data and also provide cost-effective solutions. So yeah, I'm thrilled. Next slide, please. I'm thrilled about this initiative because I really think that it's an incredible chance that we have to overcome important barriers like the ones that I highlighted in my previous slide. And I think it can bring enormous competitive advantage to the European raw material sector. However, if we want to make sure that this platform succeeds, collaboration between the public and the private sectors is essential. Next slide, please. And of course, collaboration starts with the data. This is one of my favorite covers of The Economist of all time. Some of you may have read actually this issue. And the title was Data is the New Oil. And I mean, we're not here referring to oil as a dirty fossil fuel, but the main analogy here is that data is a source of power. And I don't think this can be more true than with Earth observation. It's a data source that is extremely, extremely valuable to understand the Earth's resources, including mineral resources, of course. And if we're looking at the value of this data, we need to understand that public data, especially Copernicus, has to be the cornerstone of the platform. All of you, or most of you, will know that Sentinels have revolutionized Earth observation, positioning Europe really as a leader globally in EO, because Copernicus data that Sentinels have provided for free and as a public good, a resolution, a revisit time, a coverage, and a radiometric quality, which was unprecedented for public data sets. So Copernicus has to be at the heart of the platform, but if we want to make sure that this platform is successful, we also need to draw from complementary private data providers that can build on and enhance what Copernicus already provides. This means optical and radar data that will be complementing Sentinel-1, Sentinel-2, and even Sentinel-5P, improving and enhancing the spatial resolution, the spectral bands, temporal resolution, and even Perfect. Everyone can see my screen, my slides? Yes, perfect. Okay, great. Thank you. And I'm sorry for the technical hiccup, but we're back and better than ever. So as I was saying, well, data is the new oil. And again, understanding data as a source of power, which means that we need to have both public data, of course, Copernicus in this platform, but then also the complementary private sector data sources that can really enhance what Copernicus provides. And as I was saying before the problem, we have an opportunity to not only include different data sources in this platform, but really to try to lead globally, leveraging the power of data fusion. And this is an enormous opportunity for Europe to lead and for the raw materials sector to lead, because there's still no industry which has really, in a comprehensive or structural manner, actually leveraged the power of Earth observation data fusion, although there's a lot of promising results within research that show that, especially for machine learning and the training of algorithms, fusing data sets can be very, very, very powerful. And if we integrate this capacity into the platform, I think we can have an enormous competitive advantage here. Next slide, please. So exactly, so public and commercial data will be the fuel to a successful platform. However, if we want this platform to be successful, the key will really lie in the capacity to put this data to work and to be able to translate the value of the data for the raw materials sector. We need to overcome the barriers for adoption by providing insights and providing solutions to end users and not raw data. And the platform has to be able to provide this. And for this, we really need engagement from the downstream commercial Copernicus ecosystem, which is extremely active in other applications and now needs to focus in mining. We need companies, we need innovators, and we need solution makers that will take the data and will transform it into useful services for the data, for the sector. These services may go as far as to include technical support paired with the analysis of the data, so that on the user side, we don't need to have Earth observation competences to really understand and correctly use the results from the analysis, so that this technical capacity is not a barrier for adoption. We need to go as far as possible down the value chain and as close as possible to users. Again, in the downstream ecosystem, we have a great opportunity for Europe to lead in the creation of solutions for raw materials that can then be served to the global raw materials market. Next slide. And I would like to leave everyone joining us today with these two figures. The first one is 119 and 15.9 billion euros. This is the revenue from the top 40 mining companies in EMEA in 2020. And 16% is the growth rate of the revenue of these companies between 2019 and 2020. Mining has been one of the few industries that has really come out of the COVID crisis in excellent financial and operational shape. 2020 was in fact a banner year for the mining sector. The sector has enormous potential and we should tap into it and not waste it. If I can leave you with two things before the end of the presentation, those will be, firstly, we have enormous data wealth already available today. We just need to make sure that the platform leverages this wealth. And secondly, on the downstream side, we need to make sure that we increase awareness within the downstream community. The downstream Earth observation ecosystem has to look closely at the mining industry. We already have the data, but a lot of work is needed by innovators and by developers to ensure that we provide a growing sector with the tools that they need to thrive. Next slide. Well, thank you very much. That is all from me. I look forward to any questions, and also I look forward to any further contact. So you have my email there for usage. I'd be really happy to continue discussing this topic, as hopefully I've shown that I'm very passionate about it. Thank you.
Thank you very much, Irene, and my apologies as well to everyone, Irene included, on the slight technical issue that we had during her presentation. I think, well, first of all, it was a very good conclusion to all of the discussions we've had this morning. There was one specific question, Irene, that I suspect you can answer very easily, which is someone is asking if there are any informal communities or forums or social media for people working in mining operations and consultancies who already use Earth observation explicitly. So if you'd like to address that.
Definitely, and I'm really glad that actually there's already people reaching out on this topic. So of course, the first point of contact would be the FIRE Forum. These are the kind of people that we really want to be talking to as well, so that we can use them as examples and actually help them become successful within the raw materials sector. And for this reason, the second point of contact would be EIT Raw Materials. I mean, there you have an enormous community, and Patrick can speak to this, of raw materials actors that need to become aware of the potential of Earth observation and that need evangelism of sorts. So, so yeah, tap into those. Please get in touch with me. I think my slides were not on the screen, so my email is irene@planet.com. It's very easy. And yeah, like, please contact me about this and I'll get you in touch with the relevant people.
Thank you, Irene. And my personal thanks to all of the speakers from this morning's session. I can tell you, I'm hoping that we collectively managed to convince you of the added value of this idea of developing an Earth observation platform for raw materials. I definitely am convinced after listening to everyone. And so I'm very grateful to the speakers, as I said, and many thanks to the audience. Yes, unfortunately, the only thing that didn't work too well was our word cloud idea. It's more of a word fog at the moment, I think. So I'm not sure I'll put this up, but if other people want to continue, I'm going to leave it live for a while. If you want to put it in, then we'll find some way of putting this out through social media or something. So thanks again to everyone who was involved, and many thanks to DG GROW, DG DEFIS, and ESA for taking this initiative. I think it's been very important and very welcome. Have a good day, everyone. Bye.
Bye.